application will keep on adding into this domain, and the quality of service for which the 6G is putting up, those applications will be disposed of. IIT Madras team has shown on the 6G system where point-to-point communication was done.
Welcome all of you and very good afternoon to each one of you for joining today's session. And we have Dr. Shashwat Pathak, who is our speaker for today. If we can have your videos on for today's session, that would be very helpful to make it very interactive. Thank you so much, Dr. Shashwat, for joining us today. Shashwat, where he come from a small town from India to the national impact, what he is making today. So back in 2019, he completed his engineering in electronics and communication, and he was very curious and looking for the purpose. He had already asking bigger questions on how the technology could truly transform healthcare in India. What if a diagnosis could reach a remote patient in time to save their sight or their life? And Sashwat went on to pursue his master's in communication technology, followed by a PhD from MNNIT Allahabad. But his journey was not just academic, it was deeply personal and mission driven. During his research, Sashwat developed a solution for automated cataract detection, a problem impacting millions in rural India. That innovation not only earned him incubation at IIT Patna, backed by my team, also planted the seed for his startup Electrocuriotech Private Limited. From building telemedicine systems to partnering medical devices in collaboration with AIIMS New Delhi, one of which was later transformed to Siemens, Sashwat has continuously blurred the lines between research and real-world impact. But his mission did not stop at inventing. It grew into enabling others to innovate. He became the founder CEO of ACIC MIET Meerut, one of the first community innovation centers operational in India under Atal Innovation Mission, Niti Aayog. Today, he leads the Atal Incubation Centre at GNITS Hyderabad, where he mentors startups, refines ideas, and helps founders turn prototypes into funded ventures. Recognized by DST, DBT, MIT, and the Skill Council of India as a domain expert in medical diagnostics, Dr. Shashwat Pathak is not just a technologist, he is a builder of ecosystems and a catalyst for change. As you heard it all, his story is a powerful reminder innovation is not just about technology. It's about empathy, purpose, and the relentless pursuit of solutions that matter. Thank you so much, Dr. Shashwat, for joining us today and be our guest speaker. Over to you, Shashwat.
Very good afternoon, Saritha. Thanks for this opportunity. I'll be sharing my screen. Today we are checking that what is this next generation. I'll term any of the generation which is coming after 5G as a next generation. So 6G is the next one. So I'll be continuing on this. So first thing is that I want to put something together, that what is all this discussion all about, what are networks, why these are used, what are the different scenarios, and why we need networking. Actually, 50 years before this, from today, your need was to transfer message, right? And that message was in a shorthand form, like in a telegram. I don't know that how many of you have received telegram, but you must see that how this all evolved in communication. Telegram, after that, radio was there for broadcasting one of the technology. Like some message was there, it was broadcasted from one node, it was transmitted to everywhere, everybody was hearing it. But nobody could respond to that, especially the wireless communication started with the first generation. The need was we should be able to communicate, our voice should go, right? And nobody was concerned about the quality of voice and all those things. It was the message should be coming. Like telegram was something, the message shortened into something. As soon as different things started, people started on data centric network like in 2G or something. We saw messages, we saw different things. So that was the thing. As soon as 3G came, it was the aspiration that multimedia should also be enabled. We want to hear songs, we want to share the graphics and all, right? But suddenly this multimedia thing and all the things, it is something like multimedia transfer. It has put up a kind of necessity that a complex set of applications should also come. Like first came gaming, real time gaming, teaming up with the gaming. All these things together, along with a very big bandwidth requirement, need and all. So our complexity started upping. So earlier we had trains which were operated at 60 to 100 kilometer per hour. Now we have trains who are operating at 160 kilometer per hour, and soon we will be moving in 350 kilometer per hour kind of environment. So this all, like, nobody wants to stay disconnected or something. The basic necessities, the needs of people, which are actually apt in this changing scenario. That's why these scenarios are very important. Currently, if I say why we need 6G, right? Because 5G is also there, and if you are running video over YouTube, you want to have entertainment, it is running perfectly. It was running perfectly over 4G also. Why 6G? Now take the kind of scenario where you are going to make UPI payments, or you are doing some payment online in digital economy and some transactions are there. So whatever the latency is required is 0.3 microsecond. A micro is 10 raised to power minus 6. In navigation, if there is few nanoseconds, like if a microsecond interval is there, so on earth it will be shown as a difference of 100 kilometer. That's why we need, in navigation, our need is something like a few nanosecond kind of required. In defense, we need a 1 microsecond. If you are targeting one airbase and it is going to some residential area nearby, right? Then telecommunications for 5G, it is 30 nanosecond, and broadcasting, you need a time which is having a latency of 100 microseconds. Similarly, for the data center, because everything is putting on the cloud and all, if you want to fetch some file, you guys are working in team, everything is there on cloud, you are working on a common document. If that latency is more than 1 microsecond, it will be very hard to realize the thing. And as the number of people increase on that collaborative platform, this will scale down further. E-governance, Aadhaar linked things and all those things, 10 millisecond. If you want to verify the identity of somebody, if it is going beyond 10 millisecond, system is not responsive. Transportation, like we are thinking about the navigation, auto navigation cars, self-driven cars and all. If the latency is more than 1 millisecond, there will be a lot of accidents every time. Digital signature authentication, 10 millisecond. And for the e-commerce, 1 millisecond, because if it is not happening, the customer can change their mind. So it is not just about the technicalities, it is about the consumer and customer behavior. So what we are actually doing, enabling 6G, it is something like a futuristic network which has been realized in parts. Right now, it has been realized also. Like if we are saying we are building 6G, so the requirement will be, if you are putting up the industry standard of 1 terabyte per second. So it is something like when you are moving in a railway, or you're moving on earth at a speed of 1000 kilometer per hour, then also you are going to realize a speed of 1 terabits per second. So that is the kind of excellence we are looking forward to in 6G. If we are building 6G, we need different enablers, right? So they could be at infrastructure level, they could be spectrum level, they could be protocol and algorithmic level. Then only this 6G can be realized. Like if we are saying that if we are communicating underwater, suppose a defense scenario where some submarine wants to interact with its ship, it wants to exchange some data and all, then on microwave frequency, you cannot send that data because microwaves are absorbed by water. So 6G is not about some fixed radio. It is a confluence of collection of different sets of radios which are together delivering a quality of service as per the requirement. So if we are looking forward to, so first thing is that 6G, we are emphasizing a network where there will not be a star kind of configuration, where there will be a cellular network will not be there. It will be more like a more democratized way, where different access points will be there. Like you have in your office, you have different APs, access points, for which you get your SSID, and you put up Wi-Fi ka password or username, then you get connected. Those are the access points APs. So it will be enabled by different access points. Suppose an environment where similar to your office Wi-Fi, our network is outside your office, which is giving you a good quality of service, a good connectivity, a seamless connectivity. Suppose you are moving from one access point to other access point in your office, means technically you should not lose that network, right? Mostly the access points are harmonized. Then making intense use of distributed processing, where lot of interaction between these access points will be there. That will be the massive machine to machine communication. They will be communicating like, okay, this device is connected, I'm handing over this to you. They will be interacting with themselves. It is not your task key, you are moving from one access point to other access point. You are on floor 1, you are going to floor 2, so you need to change the other SSID and change your password. Then continuing the trend of this wide coverage, like if we are talking to sub 6 gigahertz frequencies, precisely to 700 800 megahertz. Suppose we are saying that 5G is enabled. So if you are going to Charminar, it will be operating at 700 to 800 or sub gigahertz frequencies. But as soon as you are moving to some other place, it is beyond 6 gigahertz, or it is operating in other bands. So that is for 5G. For 6G, we are looking forward to terahertz band, right? So it won't be confined to, like I gave you the example of ship kind of environment where a submarine is interacting with a ship. So there the microwave at higher frequencies cannot be used. Then we should have network slicing, where different frequencies can be used in different scenarios. Then multi-access edge computing, where different edges will be processing the information and all. Suppose currently we are talking about a scenario when we are moving on Earth. Suppose this Starlink kind of environment where the unmanned aerial vehicles or the satellites are actually enabling the connectivity. Suppose there is some disaster and you have sent a drone swarm there for enabling the network, because otherwise the fixed infra, the ad hoc infra is otherwise not enabled. So those drones or the UAVs which are flying over the sky in that disaster environment, they are taking signal directly from the satellite and they are connecting the humans on Earth. So that kind of network, highly networked environment, where we are talking about not just the terrestrial network, but the non-terrestrial network also. Then leveraging this machine learning methodologies, which includes your favorite topic, which is AI. So based on this, I assume that there are three kind of enablers which are there in enabling this 6G. One will be at the infrastructure level. The network will be ultra massive. Then at spectrum level, we should have terahertz kind of bandwidth, the radio, which is supporting terahertz kind of communication, and visual light communication like the Li-Fi you must have heard. Then enablers at that particular coding level or something like that, in algorithm level. So there are different kind of algorithms which are enabling this kind of communication, where the error correction, error detection, channel modeling, spectrum, all these things are dealt. Now moving on to the key performance indicators. Suppose there is a building, a multi-story building, where different floors are there. On some floor, people are into this gaming arena. They are doing a lot of gaming and all. Others are doing the critical scientific applications and other things. So you need extreme capacity into that particular thing. So terabyte kind of communication is required into that thing. Enhance the hotspot. Suppose somebody is moving from floor 1 to floor 2, they should not think about the connectivity. Device to device, the devices are interacting with each other. Some data needs to be processed. They can interact. Then the connectivity in the remote areas, something like disaster kind of situation, somewhere where the conventional networks are not there. Check the smart rail mobility when the bullet train, the first section is coming in between Mumbai to Ahmedabad. Then the multi-sensory extended reality. Today we are ushering into era of AR, VR to the extended reality, right? We want to do the trainings and all. Many organizations are not doing the physical training. They have adopted the AR, VR, and that dimensions, and they are training their people. Like recently, Maruti Suzuki, they are training their paint shops on AR, VR. They are calling people. So there are integrated sensors into those nozzles as well, and they are checking the spread of paint as well, right? So they tell you that how much better job you are doing. The industrial automation, this training is itself the example I gave you. Then large factories like 10-minute grocery delivery. Then the autonomous mobility. Tesla ADAS 2 is already there in the market. Mahindra BE6, 9e, everybody is putting up ADAS 2. People are playing cards, putting up reels that we are driving on highway. This vehicle is driving. That is not recommended, but that is a level of autonomous mobility. So these are the key performance indicators. I will not get much into it. Whatever I described in my conversation are mostly covered into this thing. The connection density is very important. Like you can experience 10 raised to the power 6 devices per square kilometer in 5G, and in 6G 10 raised to the power 7 devices per square kilometer, right? So this is the amount of device support we are looking forward. So moving on to the enablers at infrastructure level, we should have ultra massive MIMO. Like there are 10-15 years back, your phone, if you used to come from United States, there was problem of spectrum. Like the mobile phone coming from United States were not working in India because we were operating at 800 megahertz or 900 megahertz. There they were operating at 1200 megahertz or 1800 megahertz. But now you will see that multi-band support is there, right? So your phone at once can connect to a cellular network, can connect to a Wi-Fi, can connect to a Bluetooth also, right? And it can simultaneously provide on the other band. If two bands are there on your Wi-Fi, it can simultaneously put up the hotspot also with the Wi-Fi if you have dual band Wi-Fi, right? So suppose there is a surface, antenna surface, where which is reflecting a kind of frequencies where the position of that beam from where it is getting reflected is changing the frequency, right? How deep that frequency is going inside, how it is. So those kind of holographic radio environment where from the same surface with the use of different materials we are reflecting different kind of frequencies. Different kind of frequencies means different kind of channels where we can run different kind of application. It can communicate to different kind of machines. Then the intelligent reflecting surfaces which know at what frequency we need to transmit this information. Okay, so again the same surface, but thanks to the kind of material, it is giving the different kind of frequencies which have been decided in the code book. Then user-centric and scalable self-networking, like which we talked about, the access point kind of environment rather than a kind of cell where there will be a central antenna which is broadcasting and giving you signal and you are always interacting with that cell. If you are moving, you are facing some issue of handovers and other things. Then integrated access and backhaul, like they are interacting with each other and finally they are connected through optical fiber network which is giving them the backhaul. And most important, the integrated space and terrestrial network. Suppose there is need of the network at a disaster site, so you are putting up a swarm of drones or the UAVs and they are putting up the internet and other services there. So at the spectrum level, what I can say, from millimeter wave to terahertz kind of band communication and the optical wireless communication. So I'm not digging down much into the technicalities of this. So there will be not be anything which is moving as a normal ohmic law where V is equal to IR. Here we can not say that this relation is going to be linear. At the protocol level, you see the consumer applications, industrial applications, everything is getting coordinated in one space, AR, VR space. They are learning, machines are working. Then the location specific catching is done. Devices are communicating with each other. Data centers are communicating. And the human's job is to only get the desired information rather than thinking that which button, which key to press to connect to which node, right? Now, your favorite thing that how this thing will be done, since machines will be interacting, lot many things are coming which are going beyond the normal machine and a human capability. So comes your favorite thing, the favorite hero, which is the AI. So AI for the 6G development, which will be revolutionizing this particular whole space, because it is something like using the AI and ML, we will have a ubiquitous intelligence where you need not depend on a CPU kind of environment, right? Where there is one CPU and that is interacting and guiding everybody, every node. So the computing will be on edge. You will be processing the data ubiquitously, so the node is intelligent in. So different kind of applications where the processing, network optimization and transmission will be done in this particular scenario. Now, if we are talking about a network orchestration and resource management, it is more like how we are doing the network slicing, how we are driving this ubiquitous intelligence in utilizing that kind of efficient system in place, the efficient networking, the different kind of algorithms which are routing the data through that particular path, creating those channels, how that information is getting processed. Then the distributed and decentralized learning. Each node will have its own learning experience. So it is not just going to one central repository for learning and taking the steps. It is going to be a distributed learning platform where something like this thing is happening, and we are putting up the space for decentralized learning on this network. Then solving complex optimization problems. Like suppose a network behavior is there and we have integrated it over one node, but that particular optimization problem is actually dependent on the kind of experience which is being experienced by other nodes also. So if they are also sharing their insights, how this complex optimization problem is getting formulated and solved for the complete network, because the processing is on edge. We have distributed and decentralized learning, but as a whole, the whole system is as a whole responsible for the quality of service. So in signal processing and communication technique, if I'm talking about, so it will be the end-to-end system optimization on physical layer, like which radio to choose, which kind of, what kind of channel estimation is done. Suppose you are communicating, you are sitting on a lakeside and you are having some particular like waterproof communication equipment, the phones and other things, and you try to get connected everywhere. Suddenly you change your place, you go much nearer to lake, or you are enjoying inside the lake. So what kind of radio, what kind of channel estimation, what needs to be done, it is all there. So AI will be looking after on the physical layer, like where the radio is, your radio is there, that which frequency, what kind of estimate, what kind of channel parameters needs to be taken. Then non-linear signal processing. The signal processing is not linear in this environment because the requirements are different. Suddenly you are working on some particular text kind of thing, but you want to link it to a avatar which you are creating on the AI platform. You want it to understand and simultaneously it should give the expressions also, right? So the signal processing of that data in form of text will not be limited by some particular kind of requirement for bandwidth. The bandwidth can suddenly come into burst. Then the channel estimations and detections, how the error codes and all the things will be deployed so that the channel estimation is done, so that error free in least number of transmissions your data is reached. there. Then the super resolution theory, where we are actually looking forward to particular environment where we are triggering some events which are related to some particular action, and they are into the range of nanoseconds. Then modulations and coding, different input data or the output data, what kind of modulation needs to be done. The radio will adopt what kind of modulation, the different kind of coding, the source coding, the channel coding, or whatever at the receiver you are putting. So the receiver complexity should be least. Otherwise, if the receiver complexity is more, you will keep on sending the messages, and it is highly likely that the messages will be deciphered after a very long time. So no need of 6G kind of a reminder. Now comes semantic communication and emergent protocol. Like if I talk about semantic conversation, it is something like a more meaningful communication where you are putting the data and the emotional intelligence is also coming out of data. Or if you want to put the emotional intelligence into that data, like some author orchestrating something on your behalf, and from the wordings, from the text, from the natural language processing, it reads and it orchestrates the whole particular purpose. Then the learning communication protocols, like the communication is going on in different scenarios, and as per the requirement, the bandwidth availability, the resources and other things, the things are getting learned by the system and they are getting used on a predictive basis. Then the semantic information acquisition, which is very important for doing all these things. So you should know that how the natural language processing will be working in this environment. So your AI agent will be putting up thing. So here the thing will not be done on much on the higher side on the network layer. There will be different agents which will be doing jobs which is more like edge computing, and they will be sharing their experiences within the agents, so that your task will be completed very quickly, and there will be a good lot amount of personalization as well as the native. Then AI for holographic radio and computational efficiency. So why the holographic radio? I told you the ultra massive MIMO, where millions of antennas are connecting simultaneously with millions of antennas. I'm not saying devices, I'm telling the name antennas, because this holographic surface is used in antennas, and those antenna information is processed in those devices. So think of a scenario where from a surface which is slightly more than of my palm, it is actually radiating signal simultaneously in the range of thousands, and a similar antenna is taking thousands of different signals, and it is actually linking to the different devices. So it can be made possible only with the holographic radio operations and all, and processing that information, linking that information to that device, and suddenly changing the whole matrix of that holographic surface and understanding the whole dynamic is done by AI. Then the computational efficiency and physical limit. So what could be like from a very small area, same kind of electromagnetic waves are emanating, but they are actually diverse in their application, meant for different operations. So at the receiver end also, your AI system is managing your receivers, that for which frequency, for which message, which is the intended user, and at what frequency the user has to listen, at what frequency the filter needs to be enabled, so that your electronics starts operating on that. And not just that, beam forcing the whole antenna grid, that whether this signal will be emanating into a diverse kind of environment or in a beam force kind of environment. Everything. Understanding neural networks and random matrix theory. So the neural network which are interacting in this whole ecosystem of antennas and all, so this AI will be acting as a moderator node kind of thing. So you can think that this Saritha is currently acting as an AI agent. So these are the challenges which are there for AI in 6G. And why I'm putting up these challenges, because whatever I just told you looks very fascinating, looks very interesting, it will be done, but a lot of needs to be done. So we need people like entrepreneurs like you, the researchers like you, the enthusiasts like you to these. So one of the major issue is the generalization, which the new AI enthusiasts often face. Like if you are training your data every time, so overtraining of data happens, sometimes the undertraining of data happens, sometimes the generalization happens, right? So AI will be dealing in 6G in a highly dynamic environment. So the learning also needs to be dynamic rather than the static kind of algorithms, which can also emanate this kind of generalization issue. Then theoretical foundation, like deep learning, is something like you are observing something. So deep learning is basically on hidden models which actually understand the action and reaction, cause and other things, but it is technically not that sound. If you say that tell me the science behind a deep learning kind of model you created, so that will be one of the very hardest things to prove. Then the computational complexity and data requirement, we are talking about this kind of huge data requirement, this kind of interaction between nodes, this scale of integration, this scale of device controls, because there will be a lot of switching between the devices. So try to switch on, switch off on your manually this thing. Then you see there are the MOSFET switch where you get the UPS and inverter kind of experience in your house. When light goes, there is slightly delay, and UPS mode, it instantaneously gives you light, right? But something a data center which is operating with 100 ampere of current, and suppose the switching of that with the semiconductor is not that a very easy task to do. On algorithm you can do, but how AI is going to deal with these is a very important task to understand. Then designing energy efficient and simple mechanisms, because you cannot go very complex, though machines are working, but if machines are working in a very linear way or a very complex environment, the machines tend to hang and you will need to restart the thing, which we usually do, right? Then the measurement and evaluation difficulty. So currently we don't know that what kind of matrix we will be facing in this particular. So based on that particular arrival and based on that particular rate of departure, the different agents which are enabling this particular thing, we will have to check that what is the how we can harmonize what they are doing and how they can be incorporated, their learning can be incorporated, and that can be actually streamlined so that every agent is well synced with the other agent. So future direction, developing low complexity receivers, because there will be spreading waveforms like the holographic surfaces and all will be sending the signals which will be very close in your spectrum and not very spatially well dissociated and all. So two receivers which are in very proximity, there could be a lot of noise, one can hear the crosstalks and all those things can happen, right? So for that, avoiding those crosstalks, the things on modulation, the channel coding, the coding thing, so that the crosstalks is avoided and all the things, it is important. That the optimization approaches where you understand that every time your task is not just to get the things done there, but you have also checked that what is the energy efficiency, what are the energy considerations, because you cannot have access to the infinite source of energy for running that particular system. Then exploring the potential of semantic concept so that your AI system can create a robust network which is having emotions, which is more native, and the kind of things like you going to Karnataka. So suppose you can speak in any language and the person who is in front of you can hear in Kannada or whatever they like, right? So this kind of boundary on the social front, this can also be solved in real time kind of, and the person is not actually getting integrated by all these. So that is all what AI can offer to you guys, and that's all. And I thought that 45 minutes will be enough for you so that I can interact with you guys. Thank you.
So, Sashwat, while I understand the 6G in the broadband is something the working with the kind of data usage, do we see any challenges, the kind of intensity, and then the kind of data usage which we do with the 6G, especially when we are getting with the AI, Dr. Sashwat? That's one of the
Definitely. So lot of security related issues are going to come up, and this 6G is going to address it. There has been many frauds recently where people took that digital data, this nice copy of registries, right? And telling you an incident, they put up, and that has been done in Jharkhand few years back. So they had access to the digital registry data. They picked up the thumb impressions and they utilized that data with the Aadhaar, this authentication, and had crores of rupees from their bank accounts, right? And one picture on your the social media platform, which is exposing your thumb or something, you can go into the resolution of that and you can check all the information. You can go through bank accounts and other things, right? So this needs to be the verification, the stopping, everything needs to be at the lightning fast speed. If somebody is looking into some particular kind of environment or taking the thumb impression or something, won't you feel that there should be some kind of due diligence if somebody is looking forward to this kind of data? Or if you are posting your picture, something related to this, the system itself realizes that this could pose a kind of threat to you, so it blurs or uses some other matrices so that that information is not easily available to anybody.
That's very interesting topic because I personally had this scarcity of using the digital applications in my initial times. Like there is always a possibility of getting into those frauds, and then sometimes you might not be even intentional when you are posting the pictures because you might not think of it, right? For the photos and all of it. So that's very interesting, and then it's great to know that this 6G with the AI support would help us to blur those and avoid those things. We have another question from one of our audience is how are we going to handle data pose risk or adversarial attacks? Mm.
So these kind of thing, like in a multi-agent environment, you can create different agents which are consistently sniffing these kind of things, right? So it is not just the network enablers, but the network builders whose job is, when there is data transfer or something, they are sniffing these things, right? So anything which is going out of the matrix of the usual traffic or something like that, it senses it and it alerts you.
Another question is do we have this already implemented any of the services with the 6G or it is in the built-in status?
6G, recently in India Mobile Congress earlier this year, IT Madras team has shown on the 6G system where point-to-point communication was done, right?
Okay.
And they have experienced a real-time bandwidth of 1000 gigabit per second kind of thing, right? But it is point-to-point kind of thing. Highly directional antennas were there in between. 6G is basically a confluence of lot many radios, lot many technologies to deliver a particular quality of service, right? So application will keep on adding into this domain, and the quality of service which for which the 6G is putting up, those applications will be disposed of.
And there is one more question that can small or rural areas afford the technology needed for AI based 6G? Or is it only limited to the tier one cities, the big cities? The
So
benefit of
I
6.
would like to comment that when precisely I used Geo 4G 2014 or 15, I have seen, means it was Allahabad, NIT Allahabad, and I have seen around the labor chalks the people doing video calls very often. We were not doing it, right? So even from that particular thing, you can see that these days the use of technologies, making the reels and all the things, is done majorly, means the people, it is more democratized, right? So I cannot say that the moment it will be coming to the metros, it will be enabled directly to the rural areas. But yes, it is getting adopted. It will be adopted. It is just a matter of time.
All right, thank you. Any last minute questions? I think that was all the questions what we had, Dr. Sashwat. And thank you so much. I really appreciate your time and providing the insights on this, Dr. Sashwat. And thank you everyone for joining our session and encouraging this and for asking all the questions, guys. I think we are just on time. Thanks
Yeah.
everyone. You have a great weekend, all of you. We will see all of you again with another interesting topic next week, guys.